When you're conducting a security assessment on a host, an IP address, or even a range of IPs, it's crucial to understand the sort of landscape of the targets before you launch the actual attack. Once you've identified what your targets are, one of the first things you're going to want to do is enumerate those targets. And port scanning is one of the first steps in the enumeration phase of a pen test. You think about, well, are you dealing with a web server hosting a website? Is it an Apache server, an IIS server, Nginx? Or is it a mail server? It's crucial for us to identify which ports are open, which services are being run on those ports, identifying the underlying operating system, the software versions in use. This is all done to help us search for vulnerabilities that can be exploited, as well as software misconfigurations that can be taken advantage of. The goal of enumeration essentially is to gather enough information to allow us to identify potential attack vectors, as well as develop a plan for further testing. So when we think about port scanning is essentially just the process of scanning a target host, a range of hosts, and we're basically just looking for open ports. Ports are like these virtual communication endpoints used by all networking systems or programs, basically just to send and receive data. And so by scanning for open ports, we can essentially identify, in most cases, which services or applications are running on a target system, which once again can help identify potential vulnerabilities down the road. And this can be done by using various tools, obviously the most common being Nmap, but there are a bunch of other ones like RustScan, for example, and other scanning techniques that can be used in place. And port scanners can speak, TCP SYN, TCP Connect, as well as UDP, which we'll also get into later on. But when we think more about what ports are, a port is just sort of, as I said, this sort of communication endpoint or interface that all it does is really identify specific processes or services running on a computer. So if you think about it in the example of a web server, it's going to have port 80 open if it's hosting HTTP traffic, but also it'll have port 443 open if it wants to, serve HTTPS or that, secure encrypted with TLS version of HTTP. And for example, it might want to also have SSH open on port 22 in order to allow secure remote login. And each of these ports will sort of be individually directed to or mapped internally to the service hosted on the server. And then, on the client end, you can think about having multiple browser tabs open at once. For example, the browser application sort of needs a way to determine which tab is loading which web page. And it sort of does this by establishing these consecutive connections to the remote web servers using different high-level ports on your local machine. The client is going to randomly choose a different high-level port for each connection. And so when you think about when a networking connection is made, it's made between those two ports. You have an open port listening on the server, and then a randomly selected port on the user's computer. So if you think about sort of the diagram version of this, forgive my terrible drawing, but if we just have the client here, which I'll denote as C, and then we have a bunch of different web servers out on the internet. So, we have one website here, a second one here, and then a third one. And, this could be Google, for example. Maybe we have Facebook here. So you can see we have three different web servers here. And if you think about how they're going to be offering connections, well, they're going to have, ports open. They're going to have web ports open. So, each one of them is going to have port 443 open. And I'll just make sure to denote S there, thinking about our client server model here. And so you think about the client sort of opening each of these web pages in a different tab. So we're going to have three consecutive connections here going to Twitter, Facebook, and Google. And these are going to be sort of two-way connections where we're going to be requesting data from the web server. And then obviously we're going to be getting a response back. And so again, thinking about how sort of our client or in this case, our web browser application is going to differentiate which request is coming from where. Essentially what we're going to do on our operating system is open different high-level ports for each one. For Twitter, maybe 51,082. For Facebook, maybe 12,980. And maybe for Google, we'll give it 20,003. So you can see these are random ports here. These are high-level ports. They don't typically map to a specific service. But when you think about the server side, port 443 in each of these cases, this is a standard or a well-known port for HTTPS traffic. So you think about on the server side having these well-known ports open while your client, in this case your web browser, is going to be opening these high-level ports. So hopefully that wasn't too hard to follow with my terrible drawing skills. But when you think about ports, so as I said, these are high-level ports that are open on the client side. There are a total of 65,535 available ports on every computer or server, which is obviously a lot of ports. But as I alluded to earlier, many of the available ports are sort of registered as these standard or well-known ports, such as HTTP on port 80, HTTPS, which is that HTTP traffic with a TLS encryption. That's going to be on port 443 typically. SSH traffic, for example, is going to be port 22. And then if we're thinking about mail transfer, the SMTP protocol is going to be on port 25. There are a good list of well-known ports out there, and I would encourage you to sort of memorize as many of them as you can because they do come in handy. But we can't always rely on identifying these standard ports because they're sort of just a recommendation or a standard. It's not too uncommon to see standard services move to a higher level port for either for technical reasons or maybe for the notion of security through obscurity, which again isn't always a valid security tactic, but is sometimes used. And for this point, this is sort of why enumeration is crucial. If a target's open ports and services are unknown to us, or if they're on non-standard ports, it's going to be impossible for us to stage a successful attack. And so this is where Nmap comes in. So Nmap is a powerful and the most widely used tool in the industry for performing port scans because essentially it can connect to each port of the target and in turn sort of determine whether it's that port or service is open, closed, or if a firewall is involved, potentially filtered by that firewall, and we can adjust our methods accordingly. And looking under the hood, Nmap, all it does is just send packets to the target host and then analyze the responses from the target that it receives. And through specific arguments that we can provide Nmap to adjust our scan, it can be used to identify hosts, it can identify operating systems, open ports, versions, as well as services running on the network. And once we know what ports are open, what services are being offered, paired with the version and software info, we can very quickly start to use that to our advantage and find exploitable vulnerabilities. So that was hopefully a quick introduction to what Nmap is. Obviously, we're going to get into more detail in future videos here in this series. But as to show a bit of a hands-on approach here, what we're going to do is scan this website. So this is scanme.nmap.org. And you can see here, this is a service provided by the Nmap organization. So, if you go to nmap.org, you can read all about the tool itself and the sort of organization behind it. And you can see here, they set this machine up to help people learn about Nmap and also test and make sure that their Nmap install is working correctly. And you can see the big important thing here is that we are authorized to scan this machine. Obviously, you don't want to be going around the internet scanning or port scanning random machines. Nmap is a very noisy scan, and depending on what configuration and arguments you provide or scripts, it can also be quite intrusive. So, you want to make sure you're authorized to scan anything you're scanning with, and that's why we're going to use this just for a simple proof of concept here. And all we have to do, assuming you have Nmap installed, if you're using Kali, it's obviously installed by default, but we're just going to run Nmap with no arguments or commands yet, and then we're just going to put in scan me. We just put in the host name here, but we could have done an IP address, we could have done a range of IPs, a subnet, or we could even give it a file to sort of scan from. Nmap is quite modular in that way, but for this example, we're just going to run it kind of bare bones here and just hit enter, and you can see Nmap has been started, and within a second we should get a response back from the server. And so you can see this is sort of the typical output you're going to get from Nmap. You can see we have a couple ports open here. We have SSH, as we can see under this service tab here. We have 80, obviously, for web traffic. This stranger higher port for nping, as well as whatever this elite service is going to be on this high-level port here. So you can see just sort of how easy Nmap is to use, and this is just without getting into any arguments or scripts or scans or anything like that. But once again, in future videos, we're going to go through all the different Nmap switches. We're going to go through the different types of scans you can perform. So TCP, SYN scans, UDP, for example, along with stuff with NSE scripts, as well as we'll get into firewall evasion and stuff like that. So it's going to be a good series, I hope. And I hope will be very useful if you're new to Nmap and want to learn more. So thank you once again for watching, and be sure to tune in to the next installment in this series where we cover the Nmap switches.